Okay, pre-cal, in this video we are starting Unit 7. So the first thing I want to do is tell you that we are going to learn to deal with trigonometric identities to work on proofs and equations involving our trig identities. So the very first thing I want to do in this video is talk about topic 1, and let's just define an identity. It is a statement showing the equality of two quantities. So we've already talked about some of our identities, but I want to show you the identities page that we're going to be using. The reciprocal identities we've already used in other lessons, and we've also used the quotient identities down here, but the new ones that we're going to be using are the Pythagorean theorem identities. Here they are right here, and we're also going to be using the sum and difference identities. We won't use these two right here. So I'm going to go back to the notes, and then I'm going to be referring to this page as we look through parts of coming videos. All right, so the first thing we need to do is we need to learn how to multiply and factor expressions, make a sentence, expressions with trig identities and trig functions in them. So what we want to, or not trig functions, but trig expressions. So if you'll notice in this very first example, we're going to multiply these. Now, if you'll think about this, the way multiplication works, if we were going to multiply 3x and 2x, we would get 6x squared. So something similar is going to happen here. We're going to have 6, but rather than having sine x squared, it's going to be sine squared x. Sine x squared is something different altogether, and we will not be exploring that in this particular course. So 6 sine squared x is how we write that. When we look at number 2, we have to distribute this cosine x, so 1 times cosine x is cosine x. Cosine x times cosine x, cosine squared x. Number 3, we're going to treat this just like we would if it looked something like this, like if it was two binomials multiplied together without sine in them. So we're going to FOIL this just like we would something like this. So sine x times sine x is sine squared x. Sine times 3 is 3 sine x, negative 4 sine x, and negative 12. These are like terms, so we will combine these. So we have sine squared x minus sine x minus 12. So that's what that would look like. Okay, we're going to do the same thing in number 4. We've got 2 cosine x plus 1 times 3 cosine x minus 5. So we're going to distribute this, so that gives me 6 cosine squared x, negative 10 cosine x, 3 cosine x, and negative 5. And then I'm going to combine my like terms again. Bam. And then I'm going to do the same thing on number 5. So I'm going to distribute this. So 5 and 2, that's 10. Sine squared x. Negative 5 sine x. 6 sine x. And negative 3. Easy peasy, lemon squeezy. Awesome. So we follow the same rules for multiplication that we do for everything. So I just want you to see what it looks like when we square sine or cosine, and this would apply to tangent, cosecant, cotangent, all of those. All right, so now let's look at some factoring. So I'm going to switch colors here. So now we're basically going to undo what we just did. So that's what factoring is. It's essentially dividing each of your terms by something they have in common. So when we factor, I'm going to look at my two terms. What do they both have in common that can factor out? Well, that would be a sine x. So if I take a sine x out of sine squared x, I'm left with a sine x. When I take sine x out of this sine x, I'm left with 1. So that's how you do it, just factoring. And then this one right here, we have cosine squared x minus sine squared x. That is a difference of squares, so we factor it like we would any difference of squares. Cosine x here, sine x, positive, negative. Okay, here we have a trinomial. It's going to factor into two binomials just like we would expect. Cosine squared x will be cosine x and cosine x. 3, of course, will be 3 and 1. So I've got a 3 cosine x here and a 1 cosine x here. If I want to combine those to get a negative 2 cosine x, I have to have the negative in front of the 3 and the positive in front of 1. Okay, number 9 is a little trickier because now we have a coefficient other than 1 in our lead term. So we are going to do this again, and then we've got 2 sine x and sine x. So now we want factors of 6 in these two positions that are going to combine here in a product and here in a product and then add to give me a negative 1 sine x. Okay, so let's figure out what those values are going to be. So if you'll notice here, it's not going to be 6 and 1, because if we put a 6 here and a 1 here, then that's going to give me 6 and 2. That's not going to work. So what about 2 and 3? 2 sine x and 6 sine x. That's not going to work. Let's try 3 and 2. We get a 3 sine x and a 4 sine x. Oh, that's a win. We want to make the 4 the negative and the 3 the positive. And that's how you factor involving your trig expressions.